All right, so we're going to get started in kind of the second half of chapter 3, and we're going to be talking about finding real roots of a polynomial equation. So right before break, we were talking a lot about polynomials at the start of chapter 3. We talked about like adding them and subtracting them, multiplying polynomials, dividing them. We talked about long division and synthetic division. And then we also kind of went over like what makes up a polynomial. How do you name it? How do you find the degree? What's the leading coefficient? We talked about all those like basic pieces of those polynomials. And then, like I said, we spent a lot of time with the operations. So what we're going to get into now is still working with those polynomials, but we're going to be finding the roots or the zeros or the solutions, just like we did with those quadratics when we were in chapter 2. So remember with quadratic equations, we did graphing, we did completing the square, we did factoring, we did the quadratic formula. We talked about all those different ways to solve it, to like figure out what would x equal? What are your answers? Like if I looked at the graph of a quadratic, where would it cross the x-axis at? So I want to do the same thing for this polynomial. Now the polynomial equations, they look a little bit different. Remember all quadratics kind of had like that curved U shape. Polynomials can be different, but depending on like what their degree is at. You know, if it's x to the third or x to the fourth, x to the fifth, that's going to change the number of times that your polynomial crosses the x-axis. So it either increases or decreases the amount of zeros that you're going to have. So kind of a thing to keep in mind as we go through this chapter is that when you have a polynomial, so if it's like x to the fourth power, okay, if that's the biggest exponent that you see, that means that there's at most 4 real zeros out there for that graph, for that equation. There's at most 4 answers that we could find. Some could be real, some could be imaginary. We're only going to focus on the real ones. We're not going to be spending a lot of time with the imaginary. So if we don't get all 4, if we only find 2 or 3 of them, that's probably because there's another one out there that's imaginary. And we're not going to really get into how do you find those, but we're just going to be focusing on the real roots. We're going to be using that idea of synthetic division a little bit to help us do this. Remember synthetic division from last, like the last part of this chapter, that's when we had the number up in that box that I called, and then we had the coefficients, and you guys did your synthetic division process. So we're going to do that. For this first one here, it says, given that x equals 1 is a 0. So what they're telling you right here is that this is one of your solutions. Okay, when x equals 1, the graph will cross the x-axis. So they've already given us one solution to this polynomial. Now the polynomial is 2x to the third minus 42x plus 40. I want to find the remaining ones. Since it's x to the third, that means that there's at most 3 out there. I've already found 1, so that means there's probably 2 more that I could possibly find. So we're going to try to find them. Since we know that x equals 1 is a 0, we can actually use that to help us evaluate the synthetic division or like synthetic substitution part here and help us figure out what's the new polynomial that we could use to find the last 2 roots. So remember with synthetic substitution, we did not change the sign of the number that goes in the box. So when I see x equals 1, I'm going to leave 1 as is. So don't change it to a negative 1 because I'm not trying to find a root. I'm using a root to help me find the other ones. Okay, let's think about coefficients. Look at this equation here. 2x to the third minus 42x plus 40. What term does it skip over? It goes x to the third. So it skips x to the second and then an x. What do we have to do when it skips a term? Put a 0 in. So we're going to put the 2 down first. That's the first coefficient. I have to put a 0 in for that x squared because it's missing. What's the next coefficient going to be? What number's in front of the x? Negative 42 and then 40. Okay, draw your line. Now remember, because we know x equals 1 is a root, I should not have a remainder for this problem. So remember this last piece here, that's where your remainder goes. So when I do this, I should get a 0 there. If we don't get a 0, then we did something wrong with our math previously. So you just want to make sure that you remember that for yourself. Drop down that first 2. Then you guys remember, take that 1 up in the box that I called it, times 2. So 1 times 2 is 2. That goes underneath the 0. And then you add. So 0 plus 2 is 2. Then 2 times 1 is 2. Add that to a negative 42 is going to give me what? Negative 40. Then when I take that times 1, I get negative 40 underneath the positive 40, and that's how we get that 0 for the remainder. So we did everything right. So how do we write the new polynomial using the 2, and the negative 40? It's 2x, and then what's the exponent that x gets? 2, because your original one started x to the third, so you always start 1 less. So we're going to start with x squared. And then we have plus 2x minus 40. Okay, so now if we look at this, this is a quadratic. Okay, and we know how to solve quadratics because we spent a lot of time with that in chapter 2, like I was talking about earlier, where we did completing the square and factoring and the quadratic formula and all that good stuff. So what we're going to do is try to finish this problem out by solving for that x. Figure out what are the 2 answers here. Now you've got options. You can kind of choose what you would want to do. If you like the quadratic formula, you can always use the quadratic formula. We talked about that. That's like the beauty of that formula, is that you can use it no matter what it looks like, no matter what the equation is, it's always going to work. Now what I'm going to do to try to save myself some work here, do you guys see how all these numbers, 2, 2, and negative 40, they're all even, right? So if I try to take a 2 out of everything, what am I going to be left with? If you factor out a 2, what's going to be left? Okay, and let's think about this being set equal to 0 here. Now the 2 that I pulled out is not really going to do anything because I just removed it from the problem. What I want to focus on is that x squared plus x minus 20 piece. I want to try to factor this. So remember, we put an x in each one. Now you got to think to yourself, I need 2 numbers. They have to do 2 things. They have to multiply to that negative 20, and they have to add to a 1, because there's a 1 in front of that x. So what 2 numbers would multiply to negative 20, and when I add them, I get positive 1? Negative 4 and 5. So I'm going to write x plus 5, x minus 4. Now how do I solve for x here? Set them equal to 0. So I'm going to do x plus 5 equals 0. Subtract 5 and you get negative 5. And then x minus 4, I set that equal to 0. I add 4. I get x equals 4. So your roots, or your solutions, or the zeros, remember they're going to use different words, but they all mean the same thing, are these 3 numbers. 1, because that's the one that they gave us in the problem, negative 5, and 4. Normally how I like to write them is like smallest to biggest. So any negatives and then up to your positives, just to kind of keep them in order. So I'm going to put negative 5 first. And then I'm going to do 1 and then 4. I'm going to box those up. Those are my answers. Those are my zeros. Couple things that you could do to check this. First thing is you could take those zeros, the negative 5, the 1, and the 4, you could plug it back into that function up there, and you should get a 0 when you do that. When you actually take when you take 2 times one of those numbers to the third power, minus 42 times one of those numbers, plus 40, it should come out to be 0 when you plug them in. You know, you can do that manually, like type it out step by step, or you can grab one of the yellow calculators, type it into that function that we talked about, and look at the table, and it should be right there. The other thing you could do if you have a graphing calculator is you could type in that function and look at the graph, and it should cross the x-axis at these 3 points, negative 5, 1, and 4. Okay? All right, let's do another one together. So for this one, they tell us that x equals 4 is a root. We need to find the remaining roots for this x to the third minus 6x squared minus 3x plus 44. I'm going to start this out the same way that I started that last problem in using that synthetic substitution so that I can get kind of a smaller polynomial to try to work with. So because I have x to the third here, I'm going to try to get it back down again to like x squared, a quadratic, because I know how to solve those ones pretty easily. So I'm going to put 4 up in the box area. What are my coefficients for this problem? Okay, and make sure with the 6 and the 3 you have negatives in front of them. Now this one doesn't skip over a term, like it goes x to the third, x squared, x, and then a number. So you don't need any zeros for this one. Okay, remember we should get a 0 at the end here. That lets us know that we did it right. So I dropped on that 1. 4 times 1 is 4. What's negative 6 plus 4? Negative 2. Times the 4 is going to be negative 8. So what's negative 3 plus negative 8? Negative 11. Times 4 is negative 44. And then we add that, we get a 0. Okay, so let's write this as a depressed polynomial, okay, because it goes down 1 here. So it started x to the third, our problem did. So this one's going to start x squared. Now it's 1 x squared or just x squared. You don't have to write the 1 in front. Minus 2x minus 11. And we're thinking this is like being set equal to 0 now. So I would try to factor if you can, because factoring is usually the fastest method. But if I try to think of this, I would need two numbers that would multiply to a negative 11 and add to a negative 2. 11's a prime number, though. The only factors of 11 are 1 and 11. And it has to be negative, so either 11 is negative or 1 is negative. But when I add those, I'm not going to get a negative 2. There's no way for that to happen. So factoring is not going to work for this one. Okay, this problem doesn't factor. That doesn't mean that you can't do it. Okay, that doesn't mean like, oh, all right, move on. No, it means that now you have to choose a different method. So you could use, I probably wouldn't do graphing. You could try to use the completing the square method if you want, or you could use quadratic formula, because we've talked about that and how it works every time. So remember the quadratic formula, if you don't remember that, it's opposite of b plus or minus the square root b squared minus 4ac all over 2a. Okay, remember a, b, and c, those come from the equation that we're working with. So can you guys tell me real quick what would a, b, and c be for this equation? What's your a term? 1. B would be, and C is, okay. So we're going to plug those in. So opposite of B is already a negative 2. So when I do the opposite of that, it changes it to positive 2. Plus or minus. B squared, so negative 2 squared. Minus 4 times A, which is 1, times C, negative 11. All over 2 times 1. Let's simplify here a little bit. So I'm going to have 2 plus or minus. All right, negative 2 squared is going to be positive. Anytime, remember, if you square something, whether it's positive or negative, it always comes out as a positive number. So 4. And then we have negative 4 times 1 times negative 11. That's going to be positive 44. and this is all over a 2. So now I have underneath the square root of 48. All over 2. So 48 is not a perfect square. If I tried to square root that, I'm going to get a decimal. It doesn't come out evenly. It's somewhere between 6 and 7. Because 6 is, the square root of 36 is 6, and the square root of 49 is 7. So 48 is in between 36 and 49. So it would be a decimal of 6 point something. It'd be pretty close to 7. But I'm going to try to simplify this a little bit, because I can't actually evaluate it. And I just want as close of a real answer as I can without dealing with decimals. So 48, I have to think about what's a perfect square number that can go into 48. So remember, your perfect squares are like your 4, your 9, 16, 25, 36. Now, we probably can't go over 36 because the next one's 49. That's too big. 36 is not going to go into 48. So let's think about some of those smaller ones, like 4, 9, 16. Do any of those go into 48 if I divide them? 16 times what is 48? So underneath here, I'm going to write 16 times 3. So 16 is your perfect square number. So what happens when I square root 16? What number do I get if I square root 16? 4. Okay, so 16 becomes a 4. That comes out front. So 2 plus or minus 4, and then 3 stays underneath the square root sign, and it's all over a 2. Is there anything I could do to finish this problem off? Divide it by 2. Divide all those whole numbers, the 2, the 4, and the 2, not the square root part. That's different. You can't touch that. But you can take those other numbers, you can divide them all by a 2. So what would it end up saying? One plus or minus what? Good. And it would technically be all over a 1, but you guys don't have to write that if you don't want to. So how many zeros are technically written there? Is that one answer? Or is that 2 answers? 2, because there's a plus minus sign. So I could do 1 plus 2 radical 3, there's one answer. Then I could do 1 minus 2 radical 3, there's the second one. And then they gave me 1, 4. So there's my 3 roots. And remember I said that leading degree, that x to the third, that kind of tells you how many there should be at most. So we found all 3 of them. So I'm going to put 4 right after that and say these are my zeros. 1 plus or minus 2 radical 3 and 4. All right, let's go on to the next page here. We're going to do this one together, and then I'm going to let you guys try the last one on that page by yourself here. So this one says, given that x equals 5 is a root, find the remaining of this x to the third minus 5x squared plus 4x minus 20. Okay, so I kind of want you guys to lead me through this, because I've shown you how to do this twice, and it's the same process. What's the first thing we need to do? So I put what number up in the box? 5. What are your coefficients for this problem? Good. Okay, and just, make sure that you guys check. It doesn't skip over any terms. Like it goes x to the third, x squared, x, and then your number. So you don't have to worry about putting zeros in. Okay, remember you should get a 0 for the end here. So go ahead and do that process. I'll give you a minute to fill that out. And we'll just make sure that it matches mine. Okay, check your numbers, make sure that they match mine. That's what it should look like. So when I write my new polynomial, because my coefficients are 1, 0, 4, I start with x squared, so 1 x squared, or just x squared. Then it would technically be plus 0x. Well, 0x is just 0. So I'm going to almost just kind of think of it as skipping over that term. And I'm going to go to the 4. So it's going to say plus 4 equals 0. All right, so I'm going to solve this now. It's a simple just x squared plus 4 equals 0. So, I mean, you could try to factor it if you wanted to. Or what I'm going to do is just try to solve for x like I would a normal equation. So I'm going to subtract 4 from 0. We get x squared equals negative 4. How do we get rid of x squared? How do we get it to just be x? Square root it. Okay, now I had mentioned earlier that there's possibility that you're going to have imaginary numbers. You're not going to see them a whole lot, and we don't focus a ton on them. But this is showing you one of those cases where you are going to have an imaginary number here. Because when you guys do square root of 4, what's the square root of regular 4? 2. But what do we have to include because there's a negative underneath the square root sign? I. Okay, so this is going to say x equals 2i, and we put a plus minus sign in front of it. So there's your other two roots, and then we have the 5. So my zeros are going to be that plus minus 2i, and then 5. You won't see imaginary numbers a whole lot. They do happen, but most of the time you're going to see real numbers, or like they'll show up kind of like we did on the last one with the square root still in the problem. All right, why don't you guys try to do number 4 all by yourself. Try to do the whole thing. Okay, so from what I could see, most of you got this set up. We had maybe a few mistakes out there with like multiplying, but we got that fixed and figured out. So you drop down that first 3, multiply that, okay, and it actually comes out to be -5, so you get -15. Multiply that to that -5/3, you get 25. Add that to -13, you get 12. Multiply one more time, you get -20, so we get that remainder of 0. So when I wrote this as a new polynomial using the 3, the -15, and the 12, it says 3x squared minus 15x plus 12. I saw a couple of you figure out the next step, which was to factor out something. What's a number that I could take out from all 3 terms? A 3. What's left if I take out a 3? X squared minus, good, 5x plus 4 equals 0. So this is really similar to that very first problem that we did. The 3 kind of here up front doesn't really matter anymore. So I'm going to try to factor this x squared minus 5x plus 4. So I need 2 numbers that multiply to a 4, and they would add to a -5. Good. So x minus 4, x minus 1. So if I set those equal to 0, what do I get for my zeros? If you do x minus 4 equals 0, how would you solve for x? Good. +4, +1. So my zeros are going to be that -5/3, a 1, and a 4.